In this lesson, we are going to introduce or refresh your memory on inverses. And then eventually we're going to be talking about finding inverse slopes. But let's talk about what is an inverse? What does it do? How do we know? What information can we get out of it? This is our original equation and we want to find its inverse function, we remember that the whole main idea of an inverse is if you take any coordinate from an original function, the inverse is just going to be us switching the x's and y's. So, reason I bring that up is because if we're going to find the inverse equation, we're going to find f negative 1. So if we're going to find this inverse equation, we're going to take our original equation, and I'm going to turn it into x's and y's, so 3x minus 6. And then I'm going to switch x and y. So our inverse is going to be x equals 3y minus 6. All right, and I'm going to resolve for y. So I'm going to add the 6 over. So it's going to be an x plus 6 equals 3y. We'll divide by 3, we'll divide by 3, we'll divide by 3. And so our inverse is going to be 1/3 x plus 2. So I'll finish it by writing it as the inverse function of f is 1/3 x plus 2. All right, so another layer of this is remember what an inverse does. So if you were to plug in a value on here, so let's say we were to find, this is our test point. So let's say we were to find f of 1. Okay, that would mean that we'd be plugging in 1 and we would be getting a value out of that. So we plug in 1, we multiply it by 3 and subtract 6. That's going to get us a negative 3. Right, so f of 1 equals negative 3. So kind of another look to this is we plugged in 1 and our y value was f of 1. Okay, so an inverse, what the whole idea of an inverse is, it should perfectly undo what the original did. So we simplified some stuff here, but if we multiply by 3, we should have a division of 3. There's the 1/3. If we have a subtraction of 6, we should have an addition of 6. We did, but then we ended up simplifying it out. So that's the only way that we're going to undo whatever the original one did. So if we're going to find the inverse, we're going to test this out. We're going to take this y value and we're going to plug it in and see what we get. So we're plugging in negative 3 and seeing what we get. So if we plug in negative 3, 1/3 of negative 3 is negative 1, plus 2 is positive 1. So we got out the exact same point. So they're perfect switched. So the fancied up version of this is we plugged in negative 3 in our inverse. We plugged negative 3 into the inverse equation. We got back out what we started. All right, so that's what an inverse does. So there's also a visual representation of that. If we graph this, we'll have a y-intercept down at 6, and we're going up 3 over 1, up 3 over 1, up 3 over 1, up 3, on and on and on. All right, so we have this nice line. All right, so there's our original function. And then if we graph the inverse is going to have a y-intercept at 2, and it's going to go up 1 over 3, up 1 over 3, up 1 over 3. This look to it. So there's the inverse. And how we know we did it correctly is there's a reflection between these two graphs along a 45. So a y equals x. And it goes right through the origin. So these graphs are perfect reflections along that. So that point reflects over this. They should be perpendicular to each other. They should be perpendicular to each other. And you can take every point. This is a 6/4, so this should be a 4/6. This is a 9/5. This should be a 5/9. Right? All those pieces should happen on that. All right, so that's a little bit of review. There's one other layer to this as well. This slope of our original is 3, so up 3 over 1. The inverse slope is up 1 over 3 versus up 3 over 1, right? So there's a bunch of different pieces that are kind of going on with this inverse that we're going to dive into in the calc world a little bit different, right? But that's a quick review of some main ideas of what's going on with an inverse function.